Okay, so we're going to finish our examples. We already went through the first two, and the third one is a tangent. So tangent of 2 pi over 3. We're going to go to our positive x-axis. We're going to revolve positive 2 pi over 3 to end up over here in quadrant 2. Tangent of theta. Using our reference over here, tangent of theta equals the y-coordinate divided by the x-coordinate. So looking at our point, we've got negative 1/2 comma square root of 3 over 2. So the y-coordinate of square root of 3 over 2 is going to go on top. The x-coordinate of negative 1/2 is going to go on the bottom. Since we have a fraction divided by a fraction, we're going to have to simplify. So let's look at our answer. Square root of 3 over 2 divided by negative 1/2. This is what we started with using the y divided by x. When we divide by a fraction, we can use the shortcut keep, change, flip, keeping the top, changing the division to multiplication, and flipping the bottom. So what we're really doing is multiplying by the reciprocal of the bottom. And when we simplify this, the 2 on the bottom and the 2 on the top can cancel, keeping the negative. And we're left with the negative square root of 3 on top and a 1 on the bottom. And this is a simplified answer that we can leave. So this would be our final answer. The last example uses a negative angle. So for number 4, we've got cosine of negative 5 pi over 3. This is a little trickier because the angles in negative radians or negative degrees are not listed on our circle. So we have to figure out where negative 5 pi over 3 brings us. We know we're revolving in the negative direction, but a shortcut you can use when you're trying to identify negative angles is if you find the positive angle. So right here we've got positive 5 pi over 3. If we wanted to identify where negative 5 pi over 3 is, we can reflect over the x-axis. So if I find this point up here, so if I were to fold this circle over the x-axis, 5 pi over 3 would line up with positive pi over 3. So this is where negative 5 pi over 3 would bring us on the unit circle. If you were using your conversions, pi over 3 is 60 degrees. So negative 5 pi over 3, we'd have to go negative 60, negative 120, negative 180, negative 240, negative 300. All right. So where the positive 300 was here, or 5 pi over 3. All right, so we end up here. So cosine using our reference, cosine is our x-coordinate. So at this point, all we have to do is identify the x-coordinate, which in this case is positive 1/2. And that would be our final simplified answer. So given examples, you're going to have to use this circle as your calculator. You are not typing values into an electronic calculator and hitting enter to get a decimal. We're using this unit circle as our calculator. So when you're doing the assignment online, you want to make sure that you have this unit circle in front of you. You can use this slide. You can cut and paste it if you need to, but this is the circle you need to have in front of you to evaluate your trig functions. The assignment for this section is on my hrw.com. If you need a reset password, you can email me. It's due by Friday at 2:30. So you have the whole week to complete it. Plenty of time to ask questions. You can check your answers. You can try another if you're getting it wrong. If you're not sure, like I said, you can email me. Also, if you're missing any labs that were due this term, we've had 2 labs, you can be working on those and submit them to me through Google Classroom. You can take pictures of your graphs and submit that through Google Classroom on the app on your phone. But like I said, if you have any questions, feel free to email me. Thank you guys. I will see you on our next video on Monday.